So this is Newton's second law. We learned that Newton's first law, of course, is every object in motion will stay in motion until acted upon by an outside force, and every object at rest will stay at rest until acted by some outside force. Well, then Newton had a second law, and his second law stated how forces accelerate objects. So here we got some big words here. The acceleration of an object is directly proportional to the net force acting on that object and inversely proportional to the mass of the object. So the key words here: directly proportional with the acceleration and the force, inversely proportional between the inversely proportional between the acceleration and the mass. So what Isaac Newton gave us was this formula: force equals mass times acceleration. Directly proportional with the force and the acceleration, meaning if I increase the force, that increases my acceleration. If I decrease the force, it decreases my acceleration. Inversely proportional between mass and acceleration. So increasing mass decreases acceleration. Increasing acceleration, you got to have a decrease in mass. So let's have an example here. So let's say I got a wheelbarrow, and I'm pushing my wheelbarrow with a certain amount of mass in it. And in this case, I'm just going to have a nice regular old acceleration. Now that's our baseline. What if I increase my force? Well, because force and acceleration are directly proportional, increasing my force will in turn increase my acceleration. See, you've got a big force and a big acceleration. Well, what if I decrease my force? I'm also going to decrease my acceleration because, again, they are directly proportional. What if instead we keep our force constant throughout the motion? So here we have our baseline. Well, if we decrease the mass while we're pushing with the same force, we end up with a big acceleration. So increasing the force increases acceleration. But what if our wheelbarrow gets heavier? Now, big mass, small acceleration, big mass, small acceleration. The key being that mass and acceleration are inversely proportional. As one gets bigger, the other gets smaller. And then that leads us to the work we're going to do for this assignment here. That's going to be on page 130, 1 through 5.